Hi, hello everybody. So last time we were discussing specular lights, and this time I promise that we're going to do shadows. So the shadows, they're kind of a bit difficult to explain. Well, actually not really. Let's try to do it. So, for example, if we say that we have a light here, and then this light goes from this direction. So this is just for simplicity. So this light, we can imagine as having parallel light rays, and so when it hits here, we're going to have parallel rays somewhere over here. And let's say that this is some kind of floor here, right? So we have to project it here, and then it's going to also hit here, right? Because this is the outer edge, and then it's hits here. So this region, for example, if we have some surface here, let's say this is our floor right now, and then if we have this region, so we have to shade this region and this region. So we have to shade that somehow, that region. So basically shade is here. So now that's the easy part, right? We know what the shadow is how it behaves. So now the hard part is how do we actually model that? And the thing is, it's not exactly straightforward. It's a bit hacky how we model this in basically raster engines. So basically the metal is rasterizer, it draws triangles. So what we're going to do is actually we're going to render our scene somewhere from the point of light, right? So we're going to use some huge camera, and that's going to be orthographic camera, right? Because if you remember, orthographic camera like projects parallel, right? Opposed to perspective camera, which you usually model like this, right? It was modeled like this because then if we had some cube here, this point would be smaller than this point, right? That was the point of the perspective camera. Let's forget about it for now. So we're going to use orthographic camera so that we can kind of project this, and then we're going to use depth buffer, which will store information about basically depths, and then by comparing depths later, we're actually going to kind of imagine here as having some camera as well for the light, and then we're going to compare this depth to the depth of for example this point. So we're going to get into that bit later. So this is going to be at least 2 or 3 parts video. So for the first one we just want to render to that depth texture from our scene so that we can use it later to do actually shadows. So basically, what we're doing now is trying to create a texture that's going to be used for the shadow comparison, right? So let's see. What do I mean actually by shadow comparison? Let's say that this whole ground is in texture, and then we're going to have to compare it to this depth of a fragment here, 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 etc. So it's going to be easier once we code it to understand it. It's a bit difficult to explain it like this because it's super weird. But let's get to it. So first of all, what we're going to start with is maybe creating a second scene pass. So we can essentially start by going to our coordinator and then looking at this here, we're going to have function scene pass, and here we're going to need view. So we're going to need view, okay, view, and then what else are we going to need in the scene pass? We're going to need command buffer, and you're going to see why. So here this is fine, but this one from where we create our render path descriptor until we basically say render pass and encoding. So all of this is going to be now in our scene pass. That's okay, that's okay. All right, so here we just have to say basically scene pass, and then we have view, and the second parameter is command buffer, and we probably have to unwrap it as usually. Missing argument label because I forgot this discard thingy. So here this is not nullable anymore, and then for the we're also going to have basically a shadow pass. And here we're just going to need command buffer. And then I'm going to copy all of this, but we're not going to need all of this. So basically, color attachment is not important. Depth attachment is, because we're going to render scene into depth texture. And here I just want to do this, render path descriptor, depth attachment, and then here we have this load action dot clear, and then also we have this depth attachment. What was it? I don't remember name anymore. Let's see. Store action is dot store, I believe. Let's see. Yeah, I think this is fine. So we just want to clear that buffer at the start of the frame and then store the values. Okay, let's see. What should I need? I'm just looking at some notes. Clear depth is fine. Store action, store, clear. So we don't have to render the floor, right? Because the floor is kinda last. So floor is going to receive shadows, but we cannot use just these pipelines that we had previously. So we're going to create simple pipeline, which is used just to render basically shapes, and we render so that we can actually get the depth information. So let's start with that. So for that, I'm going to need new shader, and I'm just going to call it shadow shader. Okay, cool. So here I'm going to copy unlit because there is less information here. So let's see, what do I care about? We don't care about color or texture coordinates, so we can forget about it. So here as well, we don't care about this. So we still need transforms, and we still need projection view. So we can remove this. We can change this to buffer 1 and buffer 2. And then here, this one is fine. This one is fine, and we don't need these two. And for color, we don't need basically anything except this information. Technically, we don't even need this, but I'm going to leave it regardless. And for the color, I'm just going to say 0.0, 0.0, and then 0.1 maybe. Actually, it's not even that important. What's important is what we're going to write in our shadow buffer. So let's go further. We need to create a new material for that. So I'm going to call it shadow pipeline. And similarly, I'm going to just copy unlit render pipeline and then get rid of everything that we don't need. We don't need render texture, we do need render pipeline state. So this we don't need, we do not need. One thing that I forgot, because our shaders are compiled, this is called material. So I'm just going to use shadow pigment shader and shadow vertex shader. That's probably fine. Let's see our shadow pipeline. So label shadow render pipeline, shadow vertex shader, shadow fragment shader. That's all right. Here we actually don't care about color attachment anymore. So I'm going to do this and then say invalid. You can actually render the color attachment if you want, but we don't have any use of it. You're going to see what I mean. So here I'm just going to do this. Then we do actually need render pipeline say diffuse texture, no, nothing of this. So here actually we cannot use this camera. So the point is, I forgot to mention, so it kind of works like this, right? We had this shadow, we had this cube, and then the light was projecting here and then here, but we have to use separate camera, right? that I mentioned. That's going to be kind of an orthographic camera, right? And here the point is we have to render scene from the, this is wrong. It needs to be parallel, right? So that's the point of orthographic, so that it can hit here and here edges, so that it projects the depth, right? We store this into depth information, all of this, right? This and this is stored depth buffer, and then we use it later to actually project here. So you can even forget about all of this here. So we're going to have to use second camera, and let's actually create that camera. So here I'm just going to call it directional shadow camera, maybe. So the point is we're just going to do lights from the point, from the direction. If you want, you can do that for the point lights as well, but then you have to like take whole 6 sides, so you have to project on y, negative y, z, negative z, x, and negative x. So I do not recommend it. So for this example, but where is it? Did I create it? No. But for this example, we're just going to use directional shadow camera. We're just going to do projection for the, it's here. I'm going to move it here. For the directional light. Sorry, I'm kind of trying to manage descriptions and same time looking at this. So we're going to need directional shadow camera. So let's see, high buffer we do not care about. That's not important. High buffer, right? We can get rid of this. So here we're not doing perspective anymore. We're doing orthographic projection. And let's see, I had coded this example a bit. So I used 15, 15, and then minus 15, 15. And then we just need to pass near and far as usually. So this means that let's get clear this. So our camera, when it projects, is going to go from minus 15 units to 15 units. And then the same is true here and here. All right. And then the values here, we have near. Field of view is not important for this. And we can use maybe something like 40. That's going to be fine. So we're just going to have to position that camera a bit later. And the rest of it is fine. Here. I think we're good here. Okay, cool. So I'm just going to copy this. We're going to need this information in our shadow pipeline. Comes this, and then this transformed buffer, we do need it. We do need this. So positions, all right. Color buffer and texture codes we do not care about. Transforms buffer we do care about. And then the camera buffer we do care about, but it was at position 2. And here we're passing nothing to fragment shader. And I think that we're done with our pipeline, which just needs to be called shadow pipeline. Okay, and then so just now let's add it actually here. So this is probably the easiest way. We're just going to add another pipeline to our pedal. So where is the first one? Here, private let shadow pipeline, and then here shadow pipeline is shadow pipeline device. And then we can have another draw shadow. It doesn't require light information, that's not relevant. So here I mentioned that this needs to be directional shadow camera. And then here we're just going to move this, do not care about it. Shadow pipeline, so doesn't need this information. I think all of this is relevant. So this can be probably done in an update method once, but I'm not going to do it because I'm kind of lazy, so this is just for example. But I do suggest that you maybe move this to update method so that we don't have to write this like 2 times during draw method. Not super important here. And then in shadow pass, I'm just going to say draw shadow. Ah, come on. I'm going to do it like this with a suggestion. Draw shadow. Cool. Here we can do it as well. It's all for pedal 2. And then ball, I'm just going to comment it out for now. We can just do it quickly later. And here the camera is this one. So we have to do this as well. Or shadow. Is nil, and then we just need to initialize it. Let's do that. Let me see. Ah, here. So I'm just going to shadow camera device. So now what do I want to do for position? Well, basically since we're doing it for direction light, and as you remember, it just has direction. So let's say that we're looking at some center of the scene, right? Light, let's say that this is center, but our direction, it's just a direction, so it's not important. But what I'm going to do is basically I'm just going to take one of these directions, right? In our case it was 0, 0, 0, 0, 1, I believe, for direction light here. It's a bit difficult to see. So let's do it 0, 0, 1. So I'm just going to take that and move it some units to the back. So what I'm going to do is actually do this position, and then I'm just going to use direction light dot direction, and then I want it to be negative, right? The camera needs to look into so basically if we have direction, we want the camera to be behind the direction, so that's why it's negative. And then we can just add, and you can fine-tune this always. So for me, I think this value of 10 is good. It might not even be important. So it can be also 20. So we're going to get minus 20. It's actually same as this camera position, pretty much. Or 10 is fine as well, maybe. Let's get 10. Well, let's actually run it and see what we're going to get. So I just need to pass the shadow camera, and then also the origin. We're looking at the same position. We want to look at the origin. So cmd float 3 0 0 0. Shadow camera, right? We need to update it, and then we need to pass it. Shadow. Let's try to run this. Okay, where are you? Okay, here. Well, obviously we don't see anything, but if I was to run the debugger, so you have this small metal, and let's see our render pass encoder. Aha, I never called shadow pass encoder, so you can see it here, but that's our scene depth buffer. So if I was to enlarge this is scene depth buffer. I don't care about that actually. So let's do this once more. So here we need to do not this. What was it called? Shadow pass. We need to do shadow pass. But one thing that I forgot to do, and this is very important, and I completely forgot about it. So here, while I was scoping, I did something terrible. I used this depth texture, but it's also used for the scene path right over here. Right, so we need to create a second texture, which is going to be used for basically writing this depth information. So what I'm going to do is, oh well, we can just create it similar to this one. So var shadow texture, but I want to make some small changes to this, because this is not going to work just like that. So we can say here shadow texture, texture 2D. Okay, depth texture. So we already had this information. So what I want to do further is probably take a look at that texture. Okay, create a texture. So I actually wanted to not use this. I just want to use custom width and height. So I'm just going to do similar method maybe. Actually, let's do it like this. So if width of type integer is 0, and you're going to see what I mean by this, is 0. So if our width is 0, then we can say, okay, use game width, otherwise use just width. And then we're going to do similar thing here. Then height. Okay, good. And here this one is used as render target, but we're going to have to use that depth texture a bit later, as also as a right target, or basically we're going to have to use it in a shader. So here I'm just going to need to do shader render target. Oh, where are you? Shader read, I think, as a read target as well. So basically we could pass this as a parameter as well, so that's not a bad idea either. But here I'm just going to go with it. Okay, then we're good. One more thing in our coordinator, since I want to have both dimensions same, I think this one is good. So the smaller the texture, the less quality shadow might be, but let's see what we're going to get now. So we're rendering, and let's capture this. So let's inspect that now. Okay, you can see we have two render passes, right? So here is the first one. We just drew, maybe I can somehow enlarge this. We drew two pedals. We don't see the cube yet, right? But in the second, right, where we're rendering whole scene, we can actually see here this cube as well. So now we have a texture, right? And dimensions, I don't like this. Is this correct one? Let's see once again. Dimensions are like this. Not too happy about it. Didn't I not pass them? But anyway, we have a depth texture, and then we're going to use it later in the next video when we're rendering the scene, so that we can actually render those shadows. So let me just see about this. I did paste this in. So if our width is this, we use game width, texture descriptor. Texture descriptor, we'll paste that in. Shadow texture. But I actually overwritten it because I never used it here. So the texture shadow. Okay, now probably it's going to be fine. Open. Let's see, where are you? Let's do this. Sometimes this happens, but all right, I got it. Okay, now it's correct. Now it's these are dimensions, so we're sure that we're right into the texture. Alright, that's pretty much it. Now we have the texture, and then the next time when we work, we're going to use the texture to actually do our shadows. So I didn't want to keep this too long because it might be like an hour and a half worth of videos. So let's do it next time. So if you liked a video, please like, maybe subscribe, leave a comment if you have a questions, and until next time.